Okay, this is number 2 on the page that's attached, the document that's attached to this Edmeadow video. And what you see on the page is one long rectangular looking tile picture. The rectangular tiles stand for a variable. And so on my algebra mat in class, we put a variable tile, which is the long green, and then 3 negative tiles, which are the red. Now, in the picture, you'll see that the negative tiles are shaded in. Now, that's the left side is on the left side of the equation is on the left side of the line, and the right side of the equation is on the right side of the line. Now, on the right side of the equation, on the algebra mat, the blue algebra mat, you'll see 2 positive tiles. In the picture, you'll see 2 clear tiles. Okay. So when I say left side and I say right side, I mean the left side of the equal sign and the right side of the equal sign. So x minus 3 equals a positive 2 is the equation that matches the picture that you see. Because there's an x, which is your green long tile. There's a negative 3 or minus 3, which are your 3 negative tiles. And then there's a positive 2, which are your 2 positive tiles to the right. Now, what is the inverse operation of x minus 3? To get rid of that minus 3 and get king variable, isolate king variable using inverse operations, we want to add 3. So I put 3 positive tiles on the algebra mat. And then I drew 3 positive tiles next to the negatives in the picture. And then I put plus 3 algebraically in the box. Now, I need to go ahead and add 3 to the other side, because whatever you do to one side, you do to the other. That's rule number 2 of Algebra Land. Do unto one side as you do to the other. Now, I'm adding 3. I added 3 to the left side. I have to add 3 to the right side. I did that on my algebra mat, and I drew it in the picture. And then algebraically, I put 2 plus 3 on the paper. Now I'm going to go ahead and cancel out those 3 negative tiles with those 3 positive tiles, because what happens when you put negatives and positives together? They cancel. How do you show that in your picture? You just cross off the positives and negatives that are together. How do you show it algebraically? A negative 3 and a positive 3, you just cross them out, or you could write 0. Either way is fine. And then how about 2 plus 3? Well, that's going to equal 5. So I'm going to write 5, because I have 5 chips on the right side of my algebra mat. I have 5 chips on the right side of my picture, and I have x equals 5 left. How do you check it? You plug the 5 in for x, and you rewrite the equation. 5 minus 3 equals 2, and it works. All right, let's take a look at this next one. We're going to skip down and do number 4. Now, I have 1 variable tile, which is, again, the long rectangular green tile on the left side of the line, and then I have 4 positive tiles on the left side. On the right side, I have 2 positive tiles. What algebraic equation will match this? Well, the 1 variable tile would be a variable. You could call it x or m or p or whatever variable you choose. Plus 4, because 4 is with the variable, attached to the variable in the left box. Then on the right, we have positive 2 on the right side of the equal sign. So x plus 4 equals 2 is our equation. Now, how do we isolate king variable using inverse operations? Well, since positive 4 is attached to king variable, we need to subtract 4. So add your 4 negative tiles. I'm going to draw 4 negative tiles next to the 4 positive tiles on the left side of the picture. And then I'm going to cross those out because I know that they're going to cancel. And I'm going to go ahead and write it algebraically. Positive 4 minus 4. Those 4 cancel out because of the negatives. Now, remember, rule number 2 of Algebra Land is whatever you do to one side of your equation, you have to do it to the other side. Well, we subtracted 4 from the left side. So we need to subtract 4 also from the right side. So when we do that, we're going to add 4 negative chips. Now what happens when those positives and negatives get together? How do we write that algebraically? We're going to put minus 4 below the 2. We're going to draw 4 negative chips in our picture. And we're going to go ahead and cancel out the 2 positives with 2 of the negatives. What's left? 2 negatives. We're going to cross off the 2 positives and 2 negatives that match up together in our picture. We're going to cancel out the positive 4 and the negative 4, and then we're going to say 2 minus 4. What is a positive 2 minus 4? Well, that's going to equal a negative 2. And all that's left on the left side of the equal sign is x, and on the right side, a negative 2. Now we can check it by plugging negative 2 in for x. So let's plug negative 2 into the original equation for x. The original equation was x plus 4 equals 2, so we're going to put negative 2 plus 4 equals 2. And let's see if it works. Negative 2 negative 2 plus 4 equals, if you owe $2 and you have $4, remember 4 positives, 2 negatives, you have $4, you owe 2, you're going to pay the 2, and you still